Yeah. I mean, from what that is the fair if you're going to be using like that. It's always like work at home, have the main monitor, yeah, you can just do that like have it on.
Okay, we'll start back. Okay, good. So, before the break, we wrote our first program. We saved that file. We opened up the command line or terminal. We navigated to where that file was saved. We ran the command to build the file. We verified there were no errors. And then we actually ran the file itself. We mightn't have done a lot from the point of view of what our program can do, but from the technical skill that we had to use to get to that point, we've taken a big step today. That pattern of writing your code, building your code, checking for errors, running your code has long-lasting effects or long-lasting results for us for computer programming. We're going to use that pattern for every program that we do. So I just want to go through a couple of things. The first thing I wanted to highlight, and you guys are actually really good compared to the full-timers. I noticed some spelling mistakes, but it wasn't case-sensitive most of the time. Okay? They were just general spelling mistakes. And for the most part, for the first couple of weeks of programming, that's what your mistakes will be. They will be spelling mistakes. And they're the type of ones very much like when you are learning to write for the first time, that you will spell words wrong. You'll spell them phonetically and you'll leave out silent E's and silent H's and so on. And as you get more experience, as you practice those words more often, just like as you practice your code more often, you'll get more comfortable. You won't make those mistakes anymore. But these of the first program we had there, they're the common spelling mistakes that people make. They either spell words that should be all lowercase with starting with an uppercase, or words that should have an uppercase letter at the beginning with a lowercase letter. And any of you who did make those mistakes, you'll see that it does cause an error. It does affect what happens inside the program. We also quickly, just to recap what we did, we ran our compile command, which is going to be our Java C, so Java compile, and it builds our program. We pointed at the source code we wrote, and it says, do a quality check to make sure that everything in here is a correct command. It's syntactically correct. It's grammatically correct for programming. And if it is, convert it into a Java program. And that Java program is going to be our .class file. Okay, so you'll notice on your desktop, you would have your Java file called hello-world.java, let's say. But you also then, once you ran the Java C command, you had another hello world file that was hello-world.class. And that's the actual program that was built. And then to run the program, we would just use the Java command and then the name of the program that we had. And for those of you, and this was, I suppose, of all of the mistakes that I did see, this is probably the most common one, that you might have spelt your program name different to what you called your file name. So in your code, where you had class hello world, you might have spelt that differently. Maybe you didn't have the same capitalization as you did in your file name. And that's where the hiccup came from. And that was all it was. It was just, oh, that's spelled wrong. And you fixed it, and it ended up working. And then the output was given underneath when we ran it. In this command here, we're going to specify the name of the Java program, of the name of the Java class that we want to run. And once it starts that, where it first goes to is the main method, which is where we put our functional piece of code, that command to print out to the keyboard, or sorry, print out to the screen. And again, just to reiterate, whatever you call your class here, that's what you should call your file name, and that's how you're going to be exited. That's how you're going to be running your command. If you can call your file hello-world.java, and you could have class program 1. That would work, but the difficulty you'd have, or the challenge you'd have, is remembering that you'd first of all go Java C, hello world.java. And then when you went to run the program, you'd have to have Java program 1. And the fact that they're disjointed, that they're not matching up, would lead to confusion at the beginning. And what I want to do is to eliminate as much confusion at the beginning as possible to allow for you to get comfortable with that part. So when I start actually introducing more complicated tasks, that the fundamental stuff you're okay with. Okay, and again, that's recapping kind of what we did here. All right, so let's look at the actual output statement that we used. So the first selection I have here, the system.out.println, or system.out.print, depending on which one you used, is your print command. If your command is system.out.print, it will print onto a line and it won't move the cursor at all. It will just remain at the end of that line. So if you had two print commands together, it would print both of them on the same line, but the println command moves it down to a new line. And we're going to see that in the first program that I'm going to get you guys to have a look at. So this is the command to print something onto the screen. And then the second part we have here is the thing that we actually want to print. And what we did is we put our thing that we wanted to print inside quotation marks. So it'll print that exactly. It'll say, don't do any evaluation on this, don't do any simplification on this, just take the text that's here and put it on the screen for me. And for any of you who were error-free when you were going through this, and so you had the time to edit your code so that change it from saying hello world to your name, or hello Dave, or hello Owen, or hello Jessica, or whatever it might be, you'll see that it was pretty trivial. I want that to appear on the screen so I know what to edit. I'm just going to change this word here to my name. But we're not restricted to that. I can also print out values, literal values. And what I mean by a literal value is that is the number 123. There is only one number 123, so I don't need to put quotation marks around it. It's like it's become somewhat commonplace for people to use like air quotation marks when they're being sarcastic. I'm really sorry about that. I'm really sorry about that. Whereas if you don't have that, there's no emphasis, ironic or otherwise, on the output. This is just saying, oh, that's number 123. When you put numbers into the output there, the computer will look to see, can it simplify the number or the expression you have before it outputs it. So that's a number. It can't be simplified anymore. But I could put an expression there. I could put some arithmetic in that. I could put addition or subtraction or multiplication or division. And what would happen there is it would try to solve the problem first or simplify the problem first before it would continue to actually put the stuff out on the screen. So when we're using numbers, we don't have our quotation marks. Well, why don't we have the quotation marks? We could absolutely put quotation marks around this and it still would print out 1, 2, 3 on the screen. The difference is if we have quotation marks around the numbers, they're treated as characters. Inside a computer, everything is numerical. The graphics you see, the sound that's played, the video you're watching streaming through Netflix, the email you've received, typing an email, the letters that you type in, they eventually trace back to a numerical reference of some sort. Okay? You would have started computer hardware. So when I used to teach computer hardware, one of the very first things we would do is number system conversions. Here's our decimal number system, what we normally use, 0 to 9, and then as it increases 10 to so on and upwards. And then we look at binary, which is the 0 and 1. We look at octal, which is 0 to 7, which is hexadecimal, which is 0 to 9 and A to F. And we can see that inside a computer, all it's doing is counting, and it uses different number systems to represent different types of information, but it's all numerical values. If you go even lower than that, it's all just electrical values, positive and negative voltage, representing a binary 1 or a binary 0. And that can build up to incredibly complicated, complex graphical programs, virtual reality, visualization of medical data, so like genome visualization, which you can put a VR headset on and kind of zoom into the DNA strand and see the chromosomes on it. But that all comes from that electrical system of positive and negative voltage. So when I put quotation marks around those numbers, it's not treating it as here's the value 123. It's treating it as here's the characters 1 and 2 and 3, as if you were to just type them in an email. Okay? Now, that mightn't seem too bad, but what if I wanted to do this? If I did this the way it is there, what will happen is it'll go, okay, here's a printout command. What am I printing out? Oh, hang on. I can simplify that. This is a number, this is an operator, and this is a number. And when I get a number, an operator, and a number, I can resolve that. I know how to solve that problem. And what it will do is it'll go off and it'll solve that problem, and it adds 1 to 3 and it gets 4, and it replaces 1 plus 3 with the value of 4. And this is called the substitution rule. And inside programming, the idea of the substitution rule, I can make that simpler. I've made it simpler. Here's the result. I'm going to swap out the more complicated expression and put in the simpler expression. It's really common. It's how the system executes the commands. My command here is to print something to the screen. I need to make sure that whatever's inside the brackets can't be simplified any further. Hello world can't be simplified any further. Print this exactly. Well, if it's exactly, I'm not meant to do anything with it, so I'm going to print it out. The number 123 cannot be simplified any further. It's just a number. But that can be simplified. I can solve that problem. And rather than writing 3 characters, I can write the result of just 1 character. If I had quotation marks, and do I do it here? No. Okay, if I had quotation marks around this, if I had quotation marks, 1 plus 3, close quotation marks, it would print 1 plus 3 on the screen. It wouldn't simplify it. It would just give me 1 plus 3. There's another example I'm going to show you and actually have the code up on the screen to show you how we can get very unusual after that. So we can solve calculations when they're inside quotation marks. But when we remove them outside of the quotation marks, we can solve them. And we can combine the two of them. We can have numbers and letters in the same printout statement. And not only that, we can have letters and we can have a calculation in the same printout statement. And it looks something like this. On the left-hand side of the addition symbol here, I have a quotation. The result equals. Can't be simplified any further. On the right-hand side of this first addition symbol here, I have a calculation. That can be simplified. So what would end up happening, if I just... Second. So what would happen the first time is it tries to fix this and it goes, all right, how can I fix that? Well, this I can make simpler. So get rid of that and I can replace that with 4. And now I've got result equals inside quotation marks and a plus symbol and a 4. And when you have on one side of a plus symbol some text, and on the other side of a plus symbol you have a value that can't be simplified anymore. There's no more calculation to be done. What ends up happening is we will cross out that and we replace it then with result equals 4. We just add the last value into the text, into the character. Because when it's on the screen, it can't be manipulated anymore. It's printed on the screen. It is just text on the screen. So if we simplify this expression from 1 plus 3 to the value of 4, adding the value of 4 inside the quotation marks is kind of the last step of simplifying it. And then this gets printed out to the screen. And while everybody understands this, that's addition. That is something different. What that is something called concatenation. It's the joining of a string and a value, or a string and another string together to make a larger string. If you've ever, going back to the web forms and signing up for something, when you'd sign up for something, you generally would say, put in your first name in the first box and your family name in the second box. But then when you get an email from them, or when you get a message and you log into the system, it would go, Dear Owen Carroll. It would have your full name there in the right order. And so what they did when they were forming that email is they'd have, okay, I want to have Dear, and then I want to get the first name value and I want to add that together. And then what I have now, I want to take this family name value and add that onto the end. And now I'm left with Dear Owen Carroll. And it's one line of text. And we basically did the same thing. And this is called concatenation. So if you have left-hand side numbers, right-hand side numbers, then the plus symbol means addition. And we do it the same way we've been doing math for however old you are, minus 4 years. If we have text on one side, and text or numerical values on the other side, it becomes concatenation. And that's just joining them together, super gluing them in the middle. Okay? Does that make sense? I'm going to do some experiments so you can see. Programming is one of those weird subjects where you can look at the slides and the words that I'm saying kind of make sense. You go, oh yeah, no, I understand that. But you really don't know until you play around with the code yourself and break something. It's very much a learning by doing subject. And that's why we're going to have so much practical work in this. Okay, so that's a summary of what concatenation is. One thing that you might notice that I've got extra brackets. If I go back up to that example, you can see that I've got an extra set of brackets here, which disappear in the final result. The final result is just result equals 4. So I lose these brackets. The reason why I have the brackets there is because of our mathematical operator precedence that we would have learned in secondary school. BOMDAS or PODMAS, depending on which that version of schooling you went through. And the idea is if you have something in brackets, you go to the innermost set of brackets and you simplify that first and you work your way outward. If I didn't have the brackets here, I get a really weird output, which I'm going to show you in code in a moment. Okay. 3 more slides, and then we'll go back into code, and then I'll give some problems to work on. There are different types of errors we're going to come across as we learn to program. Some of you have come across those errors already. Some of you haven't, and some of you will continue to come across different types of errors for the next couple of weeks until you get into the habit of writing code. The first type of error is a logical error. You made a mistake in the code that you wrote. You asked the program to add 203. Syntactically, there is nothing wrong with that sentence. The command is correct, the calculation is correct, you have a semicolon at the end. However, you actually wanted to compute 20 plus 3. That has got nothing to do with the computer. That is all on you. Okay? The only way you get past those type of errors is attention to detail and knowing what you're expecting out of the program. Whenever you write a program for me or for anybody, you should have an idea of what the output of that program should be. If you don't, how do you know when the program is correct? Okay? If I ask you to write a program, print your name on the screen, or write a program and print your name on the screen, you know what the output should be. I should run the program and I should see my name on the screen. So then you can go, yes, it's working correctly. And obviously we have more complicated ones. So if I ask you to, and we'll do this eventually once we get user input, take in the value of the radius of the top of the cylinder and the height of the cylinder and work out the volume of that cylinder. You might know the exact numbers, but you can test a couple of numbers. If the radius is 5 and the height is 10, well, then the output should be this. If the radius is 3 and the height is 20, the output is this. And once you've tested the formula and a couple of values, and that might be a case of getting a calculator or getting a pen and paper and working it out, you can go, no, that calculation is correct. It's following along the way it should be. And that idea of testing your output, of making sure that what comes out of your program follows along with the way it should be, is an integral part of verifying your code, of testing your code. In the second semester, you're going to have a module called Software Development 1. And that will this year look at the idea of source repositories, being able to have a source code management system, which is how industry would manage its code. We don't have a USB key with the only copy of our system on it, or only copy of the software we're building on it. We would have a special piece of software where it keeps a log of who accessed that system, what changes they made, did the changes work? If the changes didn't work, what version did they go back to get rid of the mistake that they made? And so you look at that this year. Next year, you have a software development 2. And specifically in software development 2, you look at testing. You're going to write a program, and then you're going to write a program that attaches onto it that is going to go and automate tests. What if I add 1 plus 2? What if I add 1 plus minus 17? What if I add minus 17 and 400? What if I add minus 17 and minus 17? What if I add 0 and 0? What if I add 0 and 1? And it goes through a huge combination of values. And that allows you, there's only so much you can do by hand. Your attention to detail will wane. You won't be able to keep up that attention to detail. And you don't have enough time. But if we automate it, we can go through an exponentially larger amount of testing values and really see how good our system is. So you look at that in second year in more formal ways. But logic errors are on you. Okay, that's down to an attention to detail. We have compile time errors. They're the ones you've seen so far. You've done something wrong. Here, I have the wrong type of brackets. Ignoring that the font in this one's smaller than the font in that one. But they should be round brackets, not square brackets. That, when you run it, is where you get the error on the screen. You have 1 error. You have 97 errors. You have whatever it might be. They're the best type of errors to get, because they're the ones that the program never runs. You know there's a problem, and the program will try to tell you where that problem is as best as it can. They're the best to get. They're the easiest to solve. And then the last type we have, the ones that I hate most, are runtime errors. You build the code and it runs correctly. Or sorry, it compiles, it builds correctly. There's no errors there. But when you run the code, it crashes. These are called runtime errors. A really good example of that is division by 0. If you try to divide by 0 on a computer, the computer program usually falls over. It can't handle dividing by 0. There are other ones that we get. So, for example, if you want to access a text file and that file isn't where you said it would be, unless you've built a contingency to deal with that, the program could crash there. So we'll look at a couple of runtime errors as we go through it, but they're the 3 main types of errors. Okay, what I want to do, I'll shut that one down. I want to revisit my code. And I'm going to put in some other printout statements here and just show you what they look like, and then we will have probably I'll spend about 10 minutes doing this, and then we'll have about 40 minutes or so space to work. And if you get the stuff done really quickly, you can head off early. If you need to head off early, you can head off early, or you can keep working to the end. I don't really mind. So here is our code from last time, and all this does is print out hello world. And you'll note that this is system.out.print, not println. So if I was to duplicate this line and add it underneath, so now it'll print out hello world on one line, and then it'll print out hello world again on the same line. So let me test it. Let's save this.
I need your password.
Okay, so I've built it. No errors came up. That's good. And now I'm going to run it. And you can see here I've got, there's my first hello world. And there's my second hello world. I don't want that. I want them on 2 different lines. So the way I'm going to change that is I'm going to type L for lambda and N for November. So LN for line. Okay. And now what's going to happen is it'll print hello world, and then it'll move on to a new line, and then it'll print hello world, and then it'll move on to a new line. So let me save that. Rebuild it, and run it. And you can see now I've got hello world and 2 different lines. Okay? So that's the distinction between, excuse me, print ln, and then print. What I'm going to do, don't worry too much about taking all of this stuff down furiously. I'm going to upload this onto the Moodle page once I've finished through this. What I usually do, in addition to, I'm going to add some comments in here. What I usually do for students, because I do so many examples inside a lab, is I usually set up a OneDrive folder where I save all of the source code that I do over the year, and I categorize it by week. And my intention is to do that and then put the link up on Moodle later on this evening or tomorrow morning. So for today, I'm going to put this code up on Moodle when I'm finished here, so you have access to it while you're working on your other problems. But going forward, there's going to be a link that will bring you to a OneDrive folder on my OneDrive. That will be all the source code we cover. So if I do an example in class, it's going to exist there for your reference and to have a look at it. One thing you haven't seen me do so far are these green lines here. They are comments. The comment that you write has got nothing to do with the functionality of your code. If you leave them all out, the code works the exact same way as if you write essays of comments. What they're designed for is for you, the programmer, to read it and go, oh, I understand what's happening here. So I'm going to add in a couple of comments as we go along. I would advise, as you're doing your own programs, add comments in. You will do comments the same way you're writing notes for the class at the moment. Whatever you're writing this week, or whatever you wrote last week, you're going to look back at in 6 weeks' time, and you're going to go, why did I write that then? That's really obvious. But that's your development as a programmer. You're going to write too many comments when you start off, and you start bringing it back to the stuff that's actually only necessary to write comments for. Okay, so there's printing on one line, and here's printing on 2 lines. So printing numbers. So for printing numbers, I'm going to have a value here. So let's print numbers like that, same way I did in the previous example. Let's do this here. Printing calculations. Okay, so now it's going to add, rather than printing out 123, it's going to take the number 1 and add it to the number 23 and give me 24 as an answer. Save that. And in here we have printing calculations with quotations. Okay, so line 10 just prints out a number. Print out the number 123. Line 12 will simplify this for me. It'll print out 1. It won't print it. It'll simplify. It'll take 1, it'll add 23 to it, it'll get 24, and it'll print out that to the screen. Lines 14 and 15 are showing how, if you are not careful about where you put your quotation marks, you can get very unusual outputs. So for the first one here, open quotation marks, 1 plus 23, close quotation marks. What do we think the output will be for that line? 1 plus 23. It'll print it exactly. Remember, if it's quotation marks, it's what we said verbatim. Exactly what we said. You very often hear someone, when they're giving out in the press, oh, you misquoted me. In other words, I didn't say that, or I didn't say that in that context. We should treat quotation marks the exact same way. It's exactly how we write it. If we make a mistake, again, that's a logical error. That's on us. But it'll print it exactly. Okay, so that one kind of makes sense. What do you think this one's going to do? That's a open quotation marks 1, close quotation marks, plus open quotation marks 2, 3, close quotation marks.
1, 2, 3.
Yes, you're absolutely right. It'll print 1, 2, 3. It's going to take the text on the left-hand side, 1, and it's going to take the text on the right-hand side, 2, 3, and it's going to add them together as one piece of text. And the last one I'm going to do is this. Plus that one. There. Okay, now, does anyone have an idea what line 16 will give us? So it says, open quotation marks, my answer is, close quotation marks, plus 1 plus 23.
My answer is 24.
Answer 24. Okay, does anyone have any counter thoughts?
No, because there's no brackets.
Okay, but if there's no brackets, what does that mean?
Like the first result.
You're on the right track. I was wondering what you think it means, sorry.
Like the first result.
So is
It's
it,
like an error. It's like first line.
1, 2, 3 at the end.
yes, it'll do 1, 2, 3 at the end.
To the string.
So again, going back to the idea of BODMAS, if you don't have brackets and all of the operators are the same, you start on the left-hand side and you work your way to the right-hand side. So it takes text plus a number and it concatenates them together. So then you've got my answer is 1 as the piece of text and then a number of 23 on the side. And then it goes text plus number, add them together as text. So it will go, my answer is 1, 2, 3. If we had brackets, let's do it with brackets. Then what would happen is my answer is 24 because the inner set of brackets would force itself to do it first. So it would go 1 plus 23 is 24, and then it would add it to that text on the side. Okay? So I was going to run this just to verify that our outputs are all what they should be. Okay, so, right. Oh, over there. We have hello world, that's our first output. But if you note from our first piece of code, our first output there, we still have between this command here and this command here, we have nothing to get it to move on to another line. So when we look at our output, we've actually got hello world, that's the first block. Hello world, that's the hello world from the second block. And then at the end of the println, we move on to the new line. And then we have hello world and we move down to a new line. So that's why we get 3 hello worlds in a row and then just 1 on this line here. That's printing out a number, 1, 2, 3. This is printing out the result of an equation, 1 plus 23. This is printing out open quotation marks, 1 plus 23, close quotation marks. This is printing out 1 in quotation marks plus 23 in quotation marks, which just takes the 2 pieces of text and adds them together. This is the complicated one where it goes my answer is and a 1 and adds those together. And then it goes my answer is 1 plus 23 and adds those together. And here is where we have the brackets where it forces the calculation to go first and then adds the text on at the front of it. Okay? That's a lot of output there. That's a lot of text getting added up to do different outputs. So what I'm going to do is I'm going to put that piece of code up on Moodle now. So if you have Moodle access, it will appear in a moment. And then I'm going to upload onto the screen your problems that I'd like you to have a look at. Okay. Give me one moment.
Can you change this?
Okay, that didn't work. Hang on a second. Edit settings. Okay, so now on the course notes page under week 1, the last line that we have there is the source code that we worked on this week, and so that's a link to the Java file that I had that you can have a look at. Okay, now what I'm looking for here is question 1, which I haven't got there. I got a moment. We're on the full time. Okay, I'm gonna put these up on our. Okay, I've also uploaded a digital copy of this file just so that you'll be able to have a look at it on Moodle as well. There are 4 questions on this file. For today, I'm only interested in the first 2. You can work with the other ones outside. So 2 questions. The first question is, create a program that is going to print your name, your student number, and your hair color on 3 separate lines in your program. And then the second problem is a mathematical problem. I want you to create a program to calculate how many days are in 1 century. Bearing in mind that in 1 century we have 25 leap years. Now, the actual calculation is very simple. It's a little bit of multiplication and addition. But the trick here is, I don't want you to do the computer's work for it. You can verify what the value should be. Your end value should be 36,525. That's how many days there are in a century. But I want you to force the computer to calculate that. That's the trick I want you to do for the second question. So, it is now 8:45. Let's spend the next half an hour looking at those. If you have any questions or queries, call me down and we can have a look at it. I'm going to leave the stream running. Obviously, it's a bit boring, just leave it at that, but if there's something interesting, I'll pop back up and then I'll edit it down afterwards. You are missing 1 bracket. There. So you look, you open the bracket here, you open the bracket here, you only close 1. So okay. Very common error is spotted there. You want to make sure that every time you open up 1 bracket, you always close that bracket. Okay, so that's probably the issues there.
Instead of hello words.
So what actually you can go on here then. Yeah. Okay. But you not going to worry about it. Okay, so I was just trying to Okay? Because that's, if you hit one there, it literally throws it across the and that doesn't know what you're in. Okay. No, that's fine. Okay, all right, okay. So you are currently, I don't know how that's, there, so if you're in down, it's CD. I don't know. Taking more in your bed. There. Okay, it's just you're in the wrong folder.
And what's the,
For each of these problems, you should create a brand new Java file. So you should have a Java file for question 1 and then one for question 2, and if you want to replicate for which is 36,525. Were you getting that? Yeah. How do you yeah, exactly. Well, that's one of the two main ways to do it. Yes. CLS. So, good question here. Is there a command just to clear out that command prompt? If you type CLS, it just wipes the screen. I cannot remember what it is on a Mac. I might have been saying. But on a Windows system, that's what it is. Sorry, that's in your command prompt. It's not in your Java program. It depends, right? So, if you have the Java file, you know you can do it. You know you can make that file again. So if you're looking at this, to keep the backup for you only need the Java file. Okay, zero files. That's traditionally what I do. Yeah. So you always have that. Work a lot of class up and have the Java file on the keyboard. Okay, we'll have it.
so you
So you can just yeah, if you just have the class file, you just do the upload, you get
What was the answer again?
36,525. 365 multiplied by 100 plus 25.
Okay. Right, so you have it.
First.
And now you're on that, you should have access to the whole world. I minus there from that.
Guys, if you've got the first two questions done and you're happy with it and you've no questions for me, show me the results and you're free to go. Many of you who are driving, you're going to realize it's chaos.
His results.
Eventually you will be, so don't harm us on the go.
Results, no.
So first thing I'm going to say here, see that if there's red, that means you have mistakes. That will be all wrong. And then that will that's very specific. Hang on a second. Screen. Yes. Okay, that's it. And we will do. Yeah, that's it. Go. Okay. That's all.
This line. How can I like mention this line here?
At the moment, you can't without writing that calculation again. What we need to do that is we need a way of storing information. We need to call a variable, and we won't look at that until the end of next week. Okay, so for the moment you can't. And it's absolutely okay if you end up repeating yourself in the program at the moment, because we don't have the tools to actually store information and just call that back.
Okay.
Okay. Okay, sorry. Now you misspell the question, so if you were spelling it correctly there, you were. So here's the quick tip, the first letter is happy.
And with more than one cube, keep it tablets like the show. Okay, so the protocol is coming from, I would probably.
Yeah. Yeah.
What I would use. Okay, so you have citations there. I wouldn't worry, so okay, so we try to go and save it. Same it did on my screen. Oh.
Wait.
That might be rare, I like the secondary. Okay, alright, I would also point out that whatever edits you make to this code here, you have to save. Now you need to go back and rebuild.
Guys, as you're working through these problems, the normal routine that happens is you'll try something and maybe it's not perfect, you go back to the code and you edit it. Every time you edit the code, make sure you save the file and then make sure you rebuild the program. If you don't rebuild the program in your previous version of it, let's just run the last good version you had, and that might, depending on what changes you made, might dramatically alter what the output is.
Oh, okay.
So I think the edits on that one's gonna give you.
So here, I'm gonna have to Java as well. Java seems to be
Here. So that's the one number, I'm gonna take this one here, and multiply that with the number, and then start on the left hand side, and this text in here, and then this text in here. Okay, and then we're going. Here. So you get a massive number there, and the reason for that is not that it's calculating the number. That's it. Separate parts, right, and adding that together, it's happening on the end. That was there. I would imagine. It's very tricky. So I'd say what happened is
So yeah, maybe.
there.
Things together, whatever they are. Because like when
Multiplication is natural.
Sorry guys, I completely forgot to mention it. If you want to multiply two numbers together, it's an asterisk, it's the operator in between them. Sorry. Teaching computers 14 years and I kind of assume people know stuff that I do.
Okay, yeah, so that number there is going to be, what I can show you. Yeah, that's it. Cool. Alright, and what, so let's see where the hook is up there. Alright, yeah, so it's adding the plus symbol in between them is what you missed out. Okay.
How?
Yeah.
Loading is starting.
900, like 90 million something number, yeah. Yeah, and then you realize it's an extra bracket, yeah. And the idea of that is that what would happen is we didn't have an outer set of brackets, it solves one equation, and then it solves the other, and then it goes back to the left hand side and goes text and number, add them together, text and number, add them together, and that's what you're making.
So without it, it's always, so if we're, this is always gonna come up.
With a weird, crazy big number, yeah. Whereas if you have that outer set of brackets, it goes inner and inner, it solves them, and then it goes right, take those two numbers and add them together, and then you've got your text and your 36,000. No, there's no grading for this. Don't worry, I'll let you know when this grade's going for it, because I don't want anyone to miss out. You're not able to put it. Okay. That's weird. That's it, you're done. Cool, that's great, great, excellent, good one. Yes. If you've shown me your question 1 and question 2 output, and I'm happy with it, you're free to go if you want. You're also free to stay here. Security, okay, yeah, that's not fine. It seems like okay. Yeah, no, that's exactly it. They're all. Yes, that's it. Hold on. You ready? Yeah, no worries.
Stay for one.
Yes.
Sorry for 1 second, one. Say this on my computer. Just have the.
Yes.
I have to
So is that error?
it's not the,
Yeah, that's good.
but it's not the usual. Usually that's no.
This one you're moving. You can tell you're so he recommends no competitions or applicant.
This was plus. Where you put space before the stage. Okay. Yes.
So it's all last.
Yes.
Yeah.
Yeah, what's the movement? Check.
Yeah. Yeah. And if you have any questions on that, if you want to send me an email, I can provide a detailed.
Yeah. Because I wanted to check first if I was because it starts.
For any of you who were not able to log in, so for yourself, we weren't able to log in, if you want to check if you can log into Moodle, maybe tomorrow after lunchtime. And if you can't, you send me an email, or if you send an email to the course administrators, we'll be able to figure out what the issue is at that point.
So I don't know, you know, like where it's supposed to go. So I wanted to fix it first, and then
Will you do this again?
I go with this.
Right, yep, and you are all in one.
So we did a class like.
Yeah, no, that's right.
Yeah.
Okay. Well, so there you have a multiplication and a plus. Oh, get rid of that. That still might give you a different amount. Let's see what that gives you first.
Yeah.
Yeah. And you just do you rebuild it or do you just run it again? That's you see again, yeah. What's that?
Oh, no, no.
Okay, sorry.
Okay, guys, I'm going to end the stream at this point because I'm assuming there's not going to be any other